for the riders. Keep an eye out.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So in this chapter, we'll talk about chemical bonding. And so these bonds form because bound atoms have lower energy than separate atoms. And so if the lowest energy can be achieved by ion formation, then an ionic compound is formed. For example, Na plus and Cl minus. And this gives us an ionic compound. On the other hand, if the lowest energy can be achieved by sharing electrons, then a molecule is formed. For example, CH4, and this is a covalent compound. And so this involves ion formation, and this involves the sharing of electrons. But I'll go into a little more detail about the individual bonding in a second. So, mainly valence electrons, or the outermost electrons, change position during bond formation. And we use Lewis symbols to keep track of valence electrons during this. And so let me show you the Lewis symbols real quick. So this small dot represents a single electron in the orbital. So as you can see right here, there's single electrons in each orbital. So when you have two side by side, this means you have a paired electron in the same orbital. And so for hydrogen, we would draw it like just this. It's one electron. For helium, we have a paired electron, so we would draw it like this. For nitrogen, which has 5 electrons, it would be 1, 2, 3, 4, 5, and so it has 1 paired electron and 3 single electrons, etc. Okay, so when we talk about ionic bonds, which is this example right here, you transfer dots or electrons from the metal atom to a non-metal atom. So metal to non-metal. So let's do an example. For potassium chloride, KCl, we have potassium with 1 electron in the valence shell. We don't care about the inner electrons. And then we have chlorine, which has 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. So as you can see, in order for each of these elements to achieve an octet, potassium wants to give up this electron, whereas chlorine wants to gain just 1 electron in order to get a full valence. So these two are the perfect pair, and we end up with an ionic compound. We have potassium plus, since it lost an electron, and we have chlorine that now gained an octet. But now it has a minus because it gained an electron. So an electron transfer results in an octet for each atom. There are some exceptions, such as hydrogen, lithium, beryllium. Now moving on to covalent bonds. So non-metallic elements do not form cations because their ionization energies are too high. So remember, we talked about ionization energy before, and it's the energy required to pull out an electron from an orbital. And so since that ionization energy is too high, in the case of sodium, where you have 1 electron that could be taken out, let me draw that in a circle now. This is going to be too hard because the ionization energy is great. Thus, these non-metallic elements share electrons to form covalent bonds. And so it again follows the octet rule, where in covalent bonds, atoms share electrons until a noble gas configuration is reached. And here, an important point is that the valence of an atom is equal to the number of covalent bonds. So let me show you an example. If we have one hydrogen with one electron plus another hydrogen with another electron, this would form a covalent bond in which it would share these electrons in order to get a full valence shell. And this can be drawn as a covalent bond, like so. Another example is, let's do fluorine. Fluorine, as we showed before, has 7 electrons in the outer shell. 4, 5, let's do 6, 7. Plus another fluorine. And so in order for both of these fluorines to achieve an octet, they need one extra electron. So instead of one giving an electron to the other, why don't they just share? And so we end up with fluorine sharing a bond with the other fluorine and achieving an octet. And again, just like the hydrogen 2, we can write this out as F bound to F. So the Lewis structure shows the shared electrons as a line and the lone pairs as pair of dots. So let me write out the lone pairs here as well. So this line is the shared one, and these dots are the lone pairs. So again, remember that hydrogen, lithium, and beryllium are exceptions to the octet rule, as we mentioned before when we talked about the ionic bonds.